All right, here we go. Geometric proofs, the stuff that scares everybody to death, but it's really not so bad. I'm going to try to make it really, really simple. It's not much different than the algebraic proofs we were doing before. There's just more stuff to it. But the basic breakdown of doing a geometric proof is you're going to start with your hypothesis first. Okay, start with your hypothesis, and your hypothesis is, just kind of like it was in like science and things like that. That's your statement that you're making that you want to believe is true, that you want to say is true. In geometry, in a proof, we're gonna prove with all this evidence. That's what all this stuff right here is. This is evidence, okay, that will make it true. And then our conclusion will finally be the end result, obviously, and we can conclude that this thing is true. Now, with the proof, your goal is to prove something to be true. And so if you end up proving yourself wrong, then that means you did the proof wrong, or the statement you said, or the statement you originally made never should have been made in the first place. All right. So your hypothesis should always lead you to a conclusion that your hypothesis is correct anyway. Um, but a hypothesis is also just basically the original statement that you're starting with. So, all right. Anyway, let's do an example. I think that's going to be the easiest way to do this. All right. So here's our first practice problem, and you'll see over here on the side, I've included a bunch of different theorems and um, properties of congruence and things like that. And you're going to need these things we've looked at before, but you're definitely going to need them. This is where all that vocabulary and all that kind of stuff comes back to bite you. The process we're going to follow is writing the conjecture, then drawing a diagram to represent what's happening, then state the given information, mark it on the diagram, state the conclusion of the conjecture in terms of the diagram, plan your argument, and prove the conjecture. Okay, so right now we're just going to practice writing justifications. All right, so this will be example one. Let's just write justifications. Write justifications. All right. So here we are. So we're given that angle A and angle B are complementary, and angle A is congruent to angle C. All right. So the first thing we're going to write is according to this, we're going to write the given information. So that's what we're going to say. So what's the first step of proving this thing? I'm going to say one, that angle A and angle B are complementary. Angle A and angle B are complementary. All right. And then they'll say, and I can justify that by saying because they gave that to us. So that's the thing that we'll call given. All right. So what's the second thing we can say based on this? All right. So, well, we're going to say, what does being complementary even mean? All right. This is where your definitions have to come in handy. So that we're going to say, basically saying angle A and angle B are complementary is saying that angle A plus angle B. I'm actually sorry. Let me be careful. I'm saying the measure of angle A plus the measure of angle B are going to equal 90 degrees. Okay. Well, how do we know that? And you're like, well, I know what complementary is. Okay. So that is a reason though. Okay. And so that reason is going to say that's the definition. That's the definition of complementary angles. All right. Now look at these symbols that I just wrote. Okay. This looks like an angle, right? So that's not L's, that's angles when I write that right there. COMP, that's just shorthand for saying complementary. DEF is just shorthand for saying definition of. You're going to want to know what these abbreviations mean because you don't want to write all these words out all the time. Trust that. All right, trust that. All right, so if that's the definition of complementary angles, we can't go any further than that. There's another piece of information up here, though. So we just handled this one, so now we're going to handle this. So it also says that angle A is congruent to angle C. Right? And how do we know that? Well, that's also given to us. And if that's given to us, then what else can we say? Well, if the angles, and remember when you see this congruent thing, we're talking about the shape itself. So each of those angles are congruent. So if the angles themselves are congruent, then the measures of them, which is now we're talking about the number associated with them, like if angle A was 20 degrees, then that's the measure of it. So the measure of angle A is equal to the measure of angle C as well. And how do we know that? Well, that's just the definition of congruent angles. All right. That's the definition of congruent angles. By definition, they're angles that have the same measure. All right. And so finally, what else can we do then here? So now I gotta think of what else can I say that fits this. So I can also say then, let's see, if the measure of angle A equals the measure of angle C, then that means I can go back and say that, remember when I said the measure of angle A plus the measure of angle B is 90 degrees? Then I can also say the measure of angle C, and I'm gonna write that in red. I can also say the measure of angle C plus the measure of angle B also equals 90 degrees. And why can I say that? Well, I just substituted the measure of angle A for the measure of angle C, right? Because they're the same thing. So that would be the substitution property of equality. Property of equality. All right? So if I can say that, then, so if both measure of angle C and the measure of angle B are 90 degrees, then I can finally even say that angle C and angle B are also complementary. Complementary, and why can I say that? Well, that's just the definition. By definition, that is the definition of that's the definition of complementary angles. By definition, if you add them together and they give you 90 degrees, then they're complementary. And so that was we actually just did a proof, and our conclusion was that if angle A and angle B are complementary and angle A is congruent to angle C, then our conclusion we were able to make is that angle C and angle B are also complementary. And we've just completed a geometric proof. All right.